Dr. Mark Janghese here with your Science Moment. Today I'm going to talk about why masks prevent you from hearing. That is, when you're wearing a mask, it prevents you from hearing others. And why should this be the case? Now we know that you have trouble hearing other people who are wearing masks, but a lot of people have noticed that even when they're wearing a mask, they find it harder to hear things around them. So why should that be? It's a little bit counterintuitive. Now, there's several reasons for why this is potentially happening. The most obvious, number one, is just that when you're wearing a mask, almost all of our masks are hung behind the ears. And if you just put a finger behind both ears and just slightly put pressure forward, you'll notice that you can noticeably not hear as well around you. It's just slightly pinching off some portions of your inner ear or the outer ear portions as it goes in and cutting off significant portions of the sounds around you. So that reason alone is one of the reasons why we become partially deafened when we're wearing masks. A second reason for why we're partially deafened when we're wearing masks is that when you're wearing a mask, you hear your own breathing. So for example, if you just go like this or anything that's in front of your face, you hear your own breathing very well. It's because it's the sounds are kind of reflecting back and then into the bones of your own face. You hear the sounds through your own bones of your own body. So you have a much louder self-body sound, which is then overwhelming the kinds of sounds that are coming from the outside. So that's the second reason. And a third reason that you have trouble hearing when you yourself are wearing a mask is something concerning, it's called the head-related transfer function. What that means, and let me back up to explain why this is the case. It's easy to understand why you can tell when something is to your left compared to your right. Well, it's just one ear is getting stronger signal than the other. Well, but what do you do when something is directly in front of you compared to when it's directly behind you? Or above you versus below you? In those cases, each ear is getting the same size signal, so there's no way to know whether it's directly in front of you or directly behind you or directly above you in this three-dimensional sort of space around you. How do you figure that out? Well, when something is at these various angles, like just say directly in front of you, the way the sound comes to your ears is actually shaped by the structure of your own face. The way the structure of your nose and mouth and the thickness of your bones and even the structure of your bone structure within your face and all of the aspects of your head and face affect the shape as it comes from this side, so that the envelope of sound, the range of frequencies that reach your ear, is modulated by the shape of your face in the front. And when it comes directly from the back, well, you don't have a face in the back. You have a very different kind of structure in the back. And it gets modulated. That is, the frequency ranges of sounds that come from the back are modulated differently. And from above, they're modulated differently again because the shape of the top of your head and your hair and all of the different kinds of structures going through your bones of your head this way are different from the structure, the way the sound waves go through the bones from the back. All of those things allow your brain to figure out where in this sort of two-dimensional sort of sphere around you things are coming, not just left or right. So your brain is used to those kinds of head-related transfer function modulated sounds, right? That's usually what's happening. So the first thing that happens when you put a mask on is, well, now the HRTF modulations that happen to the sound are no longer what they usually are, coming from the front. So usually you can tell things are coming from the front. You have this front-related shape to the thing, and so you can tell, okay, it's right over there. It's a little bit to my right, but it's this far forward and this far up on the basis of those kinds of shapes. With the mask there, it's entirely new. It's not what you both evolved to have the ability to recognize these sorts of directionalities, nor is it what you've learned on during your entire life. So it both prevents you from knowing the directions. It hinders your ability to tell the directions from which things are coming. Is Doug over there versus is he back there, and so on. And furthermore, since it's not the kind of sound that you're as good at receiving because it now has a different envelope shape because of the mask, then you're probably less able to even process it in the first place. Even when you can, whether or not you can figure out where it is, you may have trouble processing it as well. So these are three very distinct kinds of reasons for why the wearer of a mask becomes partially deaf or partially hindered in terms of their full auditory capabilities. And that was your science moment.